Question 3. So those who last year, your circuits was great. I saw that on the assessments at the end. Tough unit. Which of these symbols is used to represent a thermistor? A is a diode. No. B is a light-dependent resistor. No. C is a motor. No. D, gorgeous, that is a thermistor. So a resistor box with a line in it. That crookedy line for thermistor. Answer D. On to the next part. So a student investigates the current and the potential difference in a lamp. So you did this. Hopefully you'll remember me making you dance all the different shapes. There we go, hot, hot and cold. So we looked at all those voltage current graphs and we've got this as a table. It might even ask us to plot a graph, we'll see. So students use the results to calculate the resistance and we've got current. So first job, your most important formula, I'm very rich. Here's Ohm's law. And it says one value of resistance is missing. Here it is. Calculate the value of that. So we can now see, well, if I want to find R, V divided by I. So I'd have to go in here, find my V, that one, divide by that one. So here we go. Calculate it. R equals V over I. That's my V is 5 divided by 0.26 goes to 19.23. Well, there's 2 marks. Now my next mark is, and how do I decide what level of decimal points to go to here? I'm going to express it the same as the values here. So you can see just whole numbers, 19, done. 3 nice easy marks. Go on to the next part. Student writes the conclusion. The resistance of the lamp is directly proportional to the voltage. Comment on the student's conclusion. It says use information from figure 5. So I am going to have to use some of these numbers. Now, if it's directly proportional, if I doubled the voltage, I should double the resistance. That's for a quick check. I'll go from 2 to 4. That should have gone from 14 to 28. Garbage. So clearly that's why it's wrong. So I'm going to use that as an example. I could have used 1 to 2 as the example. That 11 should have gone to 22, and it doesn't. So the basic idea now is this idea of, well, if it's directly proportional, if I double the voltage, I should double the current. So here's my model answer. Well, they're certainly correct. As voltage increases, resistance increases. So we're pretty happy with that. As voltage went from 1 to 6, the resistance goes up. There's 1 mark. They're kind of right. But the next part is, are they directly proportional? No. As doubling the voltage does not double the resistance. And the crucial part is, and then use some data. So I've said, so for example, if I went from 2 to 4, it should go from 14 to 28 and it went to 18. It hasn't doubled. 3 marks. Next one, the student used a power supply that's got a fixed output voltage settings. How could they add a component that would provide or enable me to vary this voltage? And we've looked at this to death. We drew circuit after circuit after circuit of this. So the crucial thing is, I need a variable resistor. Add that to the circuit. Well, the next part is, where does it go into the circuit? I've got to connect it in series to the components. So add a variable resistor, 1 mark, and the next mark, which is tricky, in series to the components that I want to measure. Okay. And that's it. That's it. Lovely. Whiz through that one.